Hi everyone, thanks for watching this fourth tutorial of the OptoComb Suite by Kutia. Today we are going to use the OptoComb Detector toolbox to detect, identify and quantify defects on a valve body. So there are several ways to automate the visual inspection of all manufactured samples with OptoComb Detector. But here we are going to use a very powerful function of OptoComb Detector, the master sample comparison. So this valve body is a master sample, free of defects, and will serve as a reference to detect defects on a second valve body. Both have been measured with Kutia's L90 OptoComb scanner, but only the second sample's 3D data reveals the presence of three-dimensional defects. Here, here, or here. So let's send this 3D data to the OptoComb Detector toolbox. We load a master comparison recipe. Here is a master sample with target surfaces for defect inspection, and I confirm that we have the target sample ready to be inspected. The recipe is going to inspect defects within a specific range of dimensions, height, etc. We run the recipe, and in an instant, the detection algorithm can find 12 defects scattered on the surface of the valve body, and it can output statistics about their dimensions. Their length, their width, or their height, ranging here between 200 micron and 2 millimeters, but also the defect's area and volume. It also outputs the mean and standard deviation for all those values. And of course, the algorithm outputs the specific dimensions of all individual defects. So it is a very powerful and easy to use toolbox, providing that the inspection recipe is properly set. So the making of the recipe is actually pretty quick and simple, as I'm going to show you now. So let's create a new recipe. There are several ways to detect defects with OptoComb Detector. We here use the master comparison. We then need to choose a master data in this pop-up window. Here we go. Now when you scan multiple parts in a row, there are always slight differences in the position of the part with respect to the scanning area. So we need to define two bores that will serve as reference points to correctly align the master data to the target data. We set one bore in the upper left corner here, and one bore as far as possible from the first one in the bottom right corner. I apply, and here we are. Now we need to define the surfaces that we want to inspect. To that end, I use the automatic identification tool that detects the presence of walls on the part and defines all available target surfaces. I just need to set the minimum angle I want between the target surface and the walls, let's say 80 degrees. Let's check how it looks by clicking display. All right, so good. Here I can adjust the thickness of wall with those two buttons. It looks fine, so I just add all the target areas to my recipe. The algorithm will thus look at defects in every single of the areas defined in the list, and we are ready to save and to go back to the main window. Now we just need to define the minimum and maximum length and height of the target defects. So let's say the minimum length is 400 micron and the largest is 10 millimeters. And let's say the minimum height to 200 micron and the maximum one to 2 millimeters. And I validate. We also need to pre-process 3D scanning data to get rid of noise and speckles that may be found in the dataset. We just set here a simple outlier correction function, and that should be enough. And that's it. We add it to the inspection list and we are ready to run the recipe. You see that this second recipe is very similar to the first one and outputs the same number of defects and similar quantitative data. Since all inspection results are automatically saved, we can go back to the previous inspection result for comparison. And yes, both recipes output exactly the same result with the same number of defects, etc. So this was pretty simple, and once your recipe is set, you are actually ready to inspect 100% of your manufactured parts on the shop floor. As we shown in tutorial 3, the scanning software works seamlessly with the analysis software, the OptoComb Suite, so that the overall inspection process can be fully automated from measurement to data processing, data analysis, and part assessment. On that note, I thank you for watching this video, and I encourage you to learn more about 3D metrology and quality 4.0 at kutia.co.jp.